I'm here with Robert Schleip, who is both a golfer and a researcher in fascia, and he wrote a couple of very influential articles called Fascial Plasticity 1 and 2, and that's really two articles that have really made accessible a lot of the recent fascia research that we're learning about at the Fascia Conference. Robert, I wonder if you could tell me a little bit about fascial plasticity, and particularly the neurological innervation that is so important in the ability of fascia to respond to the therapist's hands.
So I only did a literature study there. I haven't done any laboratory research in that field myself, but according to the literature review I did, I had questions on the old Thixotropy model that was a classical model to explain deep tissue work like roughing, myofascial release, where if you apply like 10 pounds of pressure, you would expect the ligament to lengthen or fascia to lengthen, and that would be plastic deformation. But according to the literature, there are some big questions on that, where you would need tons of pressure to get any kind of deformation in the fascia lata, plantar fascia, etc. So probably it's not a viscoelastic response. And also I did some studies a few 10 years ago in Australia where I tried to rough somebody under anesthesia, and I didn't get much results there. So my suspicion had been, and I actually feel that's a very fertile avenue to look at the nervous system. And then we did a literature study, and we found that there are lots of sensory receptors, mechanoreceptors in fascia. And they can lead to very much changes in muscle tonus of the muscle fibers who are pulling on fascia. Even the fascia lata has lots of muscles who can change the density there. But they can also change to different hydration in the tissue itself, different circulation patterns, etc. So when we looked at fascia as a sensory organ, we found out that the fascia is actually our richest sensory organ. That in terms of the quantity of receptors that you have in fascia, if you include ligaments, retinacular, aponeurosis, all these dense collagenous connective tissues as fascia, and the intramuscular fascia, then you realize that in Euclid, and then you also look at the free nerve endings, they're all in fascia, most of them. In the periosteum you have a very high number. And many of them are not nociceptors, they are mechanoreceptors, even the free nerve endings. And you have a very high quantity of them that inform you not too much about the environment. Your retina has much fewer cells, in your inner ear, your hearing, than your fascia as a sensory organ that affects me, that tells me right now if I'm standing, if I'm falling, if I'm heavy, if I'm light, etc. So fascia as a proprioception organ. And there are 4 different kinds of mechanoreceptors, and that's what we describe in the articles. And I think that's a very rich avenue to explore. So when we manipulate fascia, I think we stimulate these 4 different kinds of mechanoreceptors, and we get different results.
So Dr. Schleip, do you mind if I pose a question really quick? You were integral in getting this conference started from its infancy.
Yeah.
So what excites you about this conference in particular? And what excites you about the future of where something like this will lead over the next several years?
Well, this conference is anybody worker's dream, to be honest. I mean, this is fantastic. And those of you who have been here in the sold-out conference, there's over 700 people here, and broadcasting it to, I think, 20 different locations worldwide in the next days. There is a sense of excitement there, and the top scientists we have interacting with clinicians. And they are listening to us, and we are listening to them, and this is really great. And there is a sense of discovery. Fascia has been neglected. It's been kind of the Cinderella of medical research, really. There was some fascia research in the 70s and the 80s of the last century, but virtually it has disappeared. And now suddenly you realize fascia is everywhere, and it's very important. And now we have the measurement technology to look at it. And this is the sense of discovery that's here at this conference. You have a similar thing happening in the field of neurology. Now suddenly they look at glia cells And they say, yeah, glial cells are everywhere. They are influencing everything. And their conferences, everything, everybody's looking at glial cells. So in musculoskeletal medicine, suddenly everybody's looking at fascia. And they say, well, if you look at the cadaver, it's everywhere. But we left it out of the textbooks. So there is a sense of Wild West discovery. And I like it. And you can see that at conference. And it definitely has been a very powerful beginning. This is the end of the first day here of the two-day conference at Harvard University. This is unbelievable to have people like Don Ingber, Gabriani here. They are nominated for Nobel Prizes, etc. Interact with us, and that we get them to look at fascia as maybe the most important application of their field of research. So there is another study, another conference planned, 2009, in the city of Amsterdam. And we don't know the date yet, so you'll get them at www.fascialresearch.com or via your